Landon.
Sticky water.
Sticky water. Good. Can anybody think of why this lesson's name is sticky water? Why? Why do you?
I'm gonna add something to water and it's gonna make it sticky.
Okay. And if I say the water is by nature sticky, do you agree? Do you remember we watched a video last time?
Yeah.
Did we? And one of the property of water is that water is sticky. Do you guys remember that part?
No.
Not much? Okay. So think about it while we are waiting for others to join. Think about how water is sticky. Can you think of any example?
Maybe water in a swamp could be sticky.
Okay.
Maybe.
Keep guessing. That's really good. Keep brainstorming about that. Like while we're waiting for others, and then we will talk about in detail. We'll wait for another 30 seconds and probably start. So, Alexa.
Do we need anything as in water for the class?
Yes. So I've kept a bottle of water with me. So if you have something where a bottle of water.
Just a normal bottle would be good?
Yes, normal water. We're not drinking or anything, just for experimenting.
So do I need like a cup to pour the water into or just normal bottle will be fine?
Normal water bottle is fine, but you guys will need a clear cup. So if you have a clear cup like this, a glass or a plastic, that'll be great. Yes. I'm just going to go over all the supplies and.
So is it like a big cup or the 2 little cups that it gave us in a bag?
You mean, are you talking about these ones?
Yeah.
We can work with this.
Actually, he gave us some like this in the bag.
Oh, no, that is for something else. We'll need a little bigger cup. If you have a glass container that's clear, that is also good. So, okay, let's check our supplies. Did you guys get the lesson 2 bag? Can you all show me or give me thumbs up? Anything is good.
Oops. Cancel.
What are you trying to do?
For all the thumbs up.
Why do you have to keep touching it?
Because like what?
Carmen is here. Hi, Quinn.
Hi.
And can you name yours? Can you all name yourself to your first name, please? Okay. So I think just Alexa, and that's all. Alexa is not here. Okay, awesome. Let's start with the supplies. Do you guys have the lesson 2 bag? Those who already gave me thumbs up, please give me one more time.
That is your bag, Sonia.
Okay. We will need a bottle of water, a bottle or, yes, a jug of water for experiment. And I want you all to have a towel with you because I don't want us to have.
I actually have like a special plate for working on so that water doesn't go anywhere. Is that fine?
That's awesome. Yes. And just in case, keep a paper towel because we have computer or tablet, whatever you're working, you are having a call with. I don't want it to get spoiled. We don't want that to happen. So just for the safety purpose.
I already have a big box of them. If I need any, just take one out.
Okay, that's awesome. Okay, now you all must have got that lesson 2 supply has this tube, right?
The experiment bottle, whatever they call it.
Yes.
Scientists use it.
Yes. Yes, that's what it is. Now, you know the rules. If you don't have something, please wave at me and unmute yourself and tell me. Let me check for more supplies. So from home, we will need some pennies, extra pennies or coins if you have. I have some, I think 15 to 20 here, but if you have like 5, 6, whatever amount you have, will be fine. We'll need a plastic fork. Okay, thanks for all thumbs up. How about you, Keegan? Do you have it? Yes, Quinn,
Can I go to the restroom real quickly?
definitely.
Thank you.
You're welcome. Okay, plastic fork, everybody. Keegan, do you have it?
Hold on, my mom forgot to get it downstairs, so my dad's going to get it.
Okay.
He's the one that's been helping me.
Okay, how about you, Carmen? Do you have any? Give me thumbs up if you have a plastic fork. Awesome, thank you. Okay. And we'll need a marker. Thank you, Carmen. A marker or a pencil and a paper. I want you to keep next to you. Okay. And did you
You gotta
get?
write something down on it.
Yes. We will be doing some predictions for our experiments. So it's easy if you can write it down and show me on the screen, then us unmuting ourselves and talking, it'd be easier and faster. Now, what I was telling, yeah, paper, parent letter. Did you all get parent letter? Can you show me? Who has the parent letter? Yes, awesome. Great. Carmen, do you have parent letter, honey? Okay, great. 1 second. Go check that. Okay, and 1 second. So this is how it looks like, right?
See?
Everybody has it? Okay. Okay. Okay, let's start it then. I think we are all set. Other than that, yes, food coloring. Any color. I have the whole pack here, but any color is good. Dishpan or a small bowl or a plate where we work on. Awesome. Thank you, Landon. Funnel, if you have, it's good. If you don't, we can work without funnel too. We'll just need a little bit help from the parent. Okay. You all got this mineral oil? Good. And pipette? Awesome. Okay. So, so we were talking about that water is sticky. Thank you. Thank you, Carmen. Now, before Carmen and Quinn joined us, we were talking about that water is sticky. How many of you agree with this statement? Water is sticky. Landon, you have something to say? No, okay. So if you agree, thumbs up. If you don't, thumbs down. You don't have to agree. Okay, great. So I see few thumbs down and yes, and few thumbs up. So those who gave me a thumbs up, how do you think water is sticky? What do you say? Let's start with Landon.
The minerals in it is sticky.
The what in it, honey?
Minerals.
Okay, so you think the molecules you mean? Sticky. Okay, that's a very good answer. Carmen, yes? Why do you think water is sticky?
Because last time, last time in our first supply kit,
Yes.
there's this blue feather. Well, my color was blue feather,
Okay.
and when I put it in the water, it was all flirty. And at first, it didn't get wet, and then it got wet, and then when I pulled it out, it was all like a stream.
Okay, that's a very good observation. Good, thank you for sharing, Carmen. Keegan, yes, why do you think water is sticky? Unmute yourself, honey. Any example where that can, tell that water?
Hey, I'm sorry, but our internet was unstable. We couldn't hear you.
Okay, so we were talking about that. I gave a statement that water is sticky, and some of you gave me a thumbs up agreeing with that. And some of you gave me a thumbs down that no, it is not. So those who gave
It doesn't have a thumbs down, does it?
No, you just gave me with the hand. Kaden gave. So let's talk about it. We were talking about water molecule in our last class. What is the other name of water? Anybody remembers? Landon.
H2O.
H2O. Very good. What does H2O mean? Who's
Water.
H2O is water. What is H in that formula, H2O? Let me write it down.
I think one of them stands for air.
Quinn.
Well, the H stands for so I know that the O stands for oxygen.
Very good. And
But the H, I think, is some kind of chemical.
okay. Thank you, Quinn. Kaden, yes.
The H actually stands for hydrogens. And since there's a 2 after the H, that means there's 2 hydrogens and 1 oxygen.
Awesome answer. Yes. H2O, H stands for hydrogen. And since there is 2 next to it, it means there are 2 hydrogen atoms and 1 oxygen atom. Hi, Sawyer. Sawyer, do you have all your supplies with you, lesson 2? Okay. So we were talking about the water molecule H2O, in which H stands for hydrogen and O stands for oxygen, and there are 2 hydrogen. And if you remember, I shared the model I made at home with the clay of H2O. So in this red is just 1 molecule of oxygen, and these 2 circles, these are 2 hydrogens. Now, if you look carefully, the hydrogen is, these 2 hydrogen they are connected to the oxygen, right? How are they connected? There's a special
They
bond.
probably stick.
Yes. So I connected with the stick, and in real life, this atom is connected to oxygen with this stick. In real life, we call it covalent bonds. Can we all say that? Covalent bond? Covalent.
And
And covalent bonds are really strong bonds. It means these two hydrogens are actually connected to this oxygen really strongly, that you cannot separate them easily. That's why water is so stable, because these bonds are not easy to break. Now, in a spoon of water, we have trillions of these molecules, trillions of these Mickey Mouses, actually. Now, how they are connected to each other. So this oxygen is connected to hydrogen here, and then another water molecule is connected like this. So at one point, one molecule of water can have 4 molecules.
Oh, do they all have whatever they called something bones, and they all hold on to each other like that?
Yes. So when the hydrogen joined with oxygen with the bond we call covalent bond, but 2 water molecules, they join together with the bond we call a hydrogen bond. So the hydrogen bond is like this. So I'm going to take a toothpick and show you. So this oxygen and another hydrogen combine together like this. So this is how the water molecules, more water molecules will come and join together.
What would happen if you took one of the blue ones off? What would happen?
This one?
Yeah, what would happen to the water?
Very good. That's a very good question. So that is when the water's chemical state changes. So when you are boiling water water starts boiling and changing into what state? What do you think when water boils, change into what state? Who's going to tell me that? Kaden.
It changes into a gas.
Very good. A gas. And what do we call that gas?
Water vapor, or maybe mist, whatever you might call it. I don't know. Maybe steam.
Yes, so I want you to raise your hands when you want to answer something, and I really appreciate those who are raising hands, okay? Yes, it's called water vapor. So when water vapor is formed when these bonds are broken, these bonds. So these bonds, they're like, these water molecules are like best friends. They always hold on hands and stay together. And that is what makes water sticky. It means when they join together, a lot of more water molecules, they are holding hands, like hydrogen bond in this case, they make a thin skin on top of water. Now let's see that skin, okay? I want you to take a cup of water, or just take a cup and put it on top of a dish pan or a plate so that we don't make a mess. Okay, and I'm going to show you, and pour water in it, in that cup. Pour it up.
No matter how much water we put in?
How much water? I want you to pour it to a point that you get a little spillover. So it has to be really full.
So up to the very top?
Very top, that you get a little bit of spillover. So a drop or two spills down to that point you have to fill.
So when we're gonna put something inside, it's gonna come out.
Who told me that just now? Mark, did you say that?
Yes.
Okay, we are going to do that.
Who's that?
Okay, let me put myself on spotlight for everyone, and I want you to see my surface here. Okay, so I'm gonna put water, and I'll stop when I see a little bit of spillover. Okay, you got a spillover, right? See that? Okay, someone's mic.
I got to the very, very top and it still didn't spill.
Okay, so then Mark, in that case, I want you to put a little bit more till it get a spill. That's important. Now I want you to look at your water cup very carefully and tell me, what do you observe before we start the experiment? Anybody observe anything different? Mark, thank you for raising hand, Mark.
I know
Yes,
something that stayed the same is the cup is still invisible and you can still see through it. And it's kind of like a magnifying glass. When you look at
Very
things,
good.
everything's bigger.
Yes, a water can be taken as a magnifying glass. Yes. Anyone else wants to share something? Any observance? Careful.
When you put something
Carmen, yes.
goes through
Okay, one second.
the wall.
Do you hear that audio noise, or it's just me?
It's somebody trying to talk.
Okay, now it's not there. Yes, Carmen, you can unmute yourself, honey.
Okay,
go ahead.
Yes. What do you see?
I noticed that the top isn't flat anymore. It's like curving.
Very good observation, Carmen. That's a very important observation you made. Yes. I want you all to look carefully. You see the top is not flat. There is a curve up here, right? Isn't it? Now, why do you think that curve is there? Anyone? Anyone else wants to share any other observation before we talk about that curve?
It's kind of like a mirror because you can kind of see if you look at something on the very top. If you look at the computer through it, you can see like two computers.
Yes.
Kind of like double.
Mark, I want you to raise your hand before you want to say something, okay? Thank you, Mark, for sharing that. Keegan, you wanted to share something. You raise your hand. Keegan, your voice is not clear. Your voice is not clear. I think you want to log out and log back in. Okay. No, it's still there. It's some audio disturbance. Okay, wait, guys. Wait. I don't know from where it's coming. Let me see. Okay.
Sometimes that feedback can come if someone has Zoom open, like on a phone and a tablet, and they're nearby. I've noticed that.
Yeah, thank you for sharing that. Anyone has Zoom open on the tablet or phone nearby? Is that why the echo coming probably? Can we all check?
No, it's bad connections because I've heard that there's something going on if the sun is making these magnetic waves come out of Earth and there's bad internet. That's why.
From my side, the internet is doing very well because I just now checked my connection, but I don't know.
I can hear it too.
Okay. Okay, let's see now if we get it again.
Hear it, honestly.
If you have a Zoom open on a tablet or a phone nearby, other than the device you have opened, can you let me know? Okay. let's look at our water. Any other observation anybody wants to share before we start? Okay, I want you to take your baggie out in which you have a coin and some paper clips.
Let me guess. We're gonna put it in the water.
Where did my bag go? Oh, it's here. So I want you to take the paper clip out. Kaden, yes.
Or well, the two sets of my paper clips are connected. Should they be connected or should I unconnect them?
You can unconnect them, yes.
Yeah, mine are connected too.
Yeah, you can unconnect them. Now I want you to, have you ever seen a video or in real life, a water strider, a water bug that can hop on water?
I've heard of them and I might have seen one.
So we are going to do the same thing what that water strider does. The goal of this experiment is to make our clip float on water. So what do you think? Do you think I should put the clip like this in water, it will float, or like this?
Yeah, put it that way.
The horizontal way?
Put it, yeah, just like you're holding it.
1 second.
Did you turn your camera off on purpose?
Nope. By mistake. Okay. So now I'm going to put the clip on water and I will use my fork. So
Wow.
do you see that it's floating?
Yeah. That's,
Yes.
hey, it sticks to the edges like there's some magnet.
Yes, it sticks to the edges. It goes to the edge because the edges are slanted. So it goes like they're downwards.
I have a question for you.
Yes.
So I think a compass works the same way, it's just like a magnet on water that turns with an arrow on it.
Mm-hmm. Okay. Actually, yes, the water compass you're talking about, I'm not sure about that. Yes, Landon.
Mine sunk.
Yes. So now if you put the paper clip like this.
I did it like this.
Yes. So this
I put it in flat and it sunk.
So the water we have, this water has a very thin skin on top of it. And the oils on our fingertips can easily break that skin. Once the skin breaks, the paper clip is going to sink down. It's like when you fill air in a balloon, the air stays in the balloon as long as the skin of the balloon is intact. The moment you put a hole in the skin, the air is going to come out, right? Similar to that, the oil in our fingers, it breaks the skin. So I want you to, so the best way to not to disturb the skin of the water, or we call it surface tension of the water, if you can put the paper clip on top of the fork like this and slowly slide it like this, it will, because the paper clip is clean, it doesn't have any oil on it, it will not break the skin of the water, or we call it the surface tension of the water. So if you are able to do it, give me thumbs up. Let's see. Awesome, Landon. Let me share your screen.
No, I wasn't. Never mind.
Anybody wants to share?
It keeps sinking. I threw 100 of them in there with a fork.
Share your screen if you got it. So show
yours.
Let her see it.
Let me see. Yes, Landon. Were
Yeah.
you honey?
You did it?
Wow. Can you all see Landon's paper clip floating? Good job. Okay. Who wants to share? Good job, Landon. Now you guys have, if you have a penny, try to use a penny or any American coin.
How about the Japanese coin? Do we use that or no?
Yes. Try the American coin and the Japanese coin and see which one floats. Anyone else wants to share?
I'm estimating that the Japanese coin will float because it feels lighter.
So after you do the experiment, share your observance with me. Why do you think which coin floated and why? Raise your
None
hand.
of them floated, and I don't know why.
Do not say the answer out loud because I want everyone to get an opportunity to think. So raise your hand if you know, if you want to say something.
And why? Is it too heavy?
Yeah, it's the ratio of the.
Okay. What's this?
This is the penny. It sank.
Float neither.
Okay.
Who wants to share? Mark, let me put you on spotlight. Wait. Okay. Do you want to share?
So none of them floated, and I don't know why.
Oh, did not float?
No, none
Do
of
you
them
have
did.
a plastic fork, Max?
I used my fork to put them in. I tried one carefully, and then I tried it hardly, and it didn't work any time.
Okay, let me see. 1 second.
Okay.
Okay, so what you do is you take your clip, put it at the edge of the fork like this. And
I already did that.
yeah, it probably will take few tries. It's tricky.
I used all of them, and now I don't know how to get them out. Hey, I just noticed that one of my paper clips has a big bubble on it when it went down. It has a big bubble. It's like sticking to it. It's a big
Carmen, you
bubble.
want to share, Carmen? Okay, let me put you on spotlight. Awesome. Very good. Do you want to put the Japanese coin, yen, and see whether it floats or sinks?
I have a question.
It sank. Okay, who has a question? I want you to try again. The Japanese coin, since it's made, Japanese coins are made of, this coin is made of aluminum and it's very light. And if you guys remember, we learned in our last class that there are a few things that are less dense than water, and those are the things that float. Quinn, yes.
Well, I accidentally dropped a tiny cup into the water and it kind of froze. There's frost all over it. See?
Can I see it? Let me put you on spotlight. 1 second.
Okay.
Yes, now show me. Is your water really cold?
No.
What is that black thing on the cup?
The black thing.
Is it black color? Oh, okay. From here I see that. I see a contrast. I see the cup is darker color here and it's lighter color here. That's what I see. So do you think it froze?
Yeah.
Is the water really, really cold?
Kind of. It's not that cold.
Okay. That's strange. Yeah. There must be some reason behind it. Yeah. Okay. Anyone else? Now let's move on to, yes, Mark.
When my last paper clip, when I tried putting it in without my finger, it had this bubble on it.
Okay.
The other ones, the ones that I touched didn't have a bubble on it, but the one that I didn't touch, for some reason, it has a bubble on it.
Yes, the bubble can form. It depends how you're putting the clip, and the air bubble can form on that. That is totally normal. Yeah. Let's do, yes, Landon.
I got it too, look.
You got it. Awesome. How many of you were able to float? Wow. Let me put you on spotlight 1 minute. Yes. Awesome, Landon. Good job. Good job. Okay. How many of you were able to float the yen and the paperclip? Sawyer, you have a question or? Okay. Unmute yourself.
We should. Well, I don't have a question, but I got to get the paperclip to float with my hand as well, not with the fork.
Very good. That needs a lot of practice. Very good. Awesome. Okay, so I want you to take the pennies out. How many ever pennies you have, I want you to take it out.
So we fish it out with our fork or with our fingers or?
No, I want you to keep, no, just leave it there. The paper clips and the stuff you have already in water, that's okay. Leave it there.
Take them out. You're fine.
Now, let's, now the next experiment is to check the strength of the surface tension of water. It means that I remember when we pour the water in the cup, Mark said that now we will not be able to put anything in the cup because the water is already overflowing, right? Do we all agree with it? Do you think we can put anything in this cup? Let me put myself on spotlight, and my cup is here really full. I can put some more water and make sure that it's very, very full. Now, if you think we can put something else in it, give me a thumbs up. It's so full that it got a spillover, okay? Give me thumbs up if you think we can put something else in it. Or if we cannot, thumbs down.
I already did that experiment because when my stuff sank, it happened. I'm not gonna say the answer out loud.
Do you think we can put some pennies in it? Like 5, 6 pennies or more than that? Do you guys think? Give me thumbs up, thumbs down. So Kaden is telling yes, we can do that. Now I want you to use your paper and marker or pencil, whatever you have, and write down a number and predict how many pennies do you think we can put in this already full cup of water. 1, 2, 5, 10, 15, 20, how much ever you think we can. Let's predict first. Now you guys have a parent letter, and that tells, if you look carefully, there are 3 trials we have to make. Every trial has a prediction. So I want you to write down that number on it, on your first prediction. Now, anybody here, can you all show me your number? Like writing on a paper and just show me like this. 3. Mark is telling 3. Okay, that's a good way. Sawyer is also telling 3. Landon is 5. Anybody else? Kaden, how much? I can't see it.
I tried to write a 1 on there.
Okay, 1. Okay. Okay, Carmen is telling 2. And Keegan? Sawyer is telling 3. Quinn is not here. Her camera is off. So what if I say we can put 20 pennies? I don't know. I would say 20.
I am here. I just have a lot of commotion going on. And when I turn on my video, I glitch a bunch.
Oh, okay. So as long as you can see us, what is your prediction, Quinn? How many pennies we can do?
I think we can do about maybe 10.
10. So let me start with mine, and then I want you to start with yours. So count with me, okay?
Okay.
Ready, set, go. 1. Now, if you see a spillover, tell me. Unmute yourself and tell me, okay? 2. Well, I already saw the spillover.
It spilled over.
Yes. Okay. Now I want you to start, all of you. Go slow. And I'm going to start over again. Do it till you get a spillover and share your number with me.
2.
Who said that? Keegan?
Me. Quinn.
Quinn. Okay, Quinn got 2. Note it down on your parent letter and do the next prediction. We'll do 3 trials, okay?
I am fitting so many pennies in here, and it still haven't spilled yet.
Very good. Keep on going till you get the spillover if you have enough pennies. Yes?
4. I got 4. Quinn.
Awesome. Who got 4?
Me. Quinn. Sorry.
Quinn. Okay. Landon, how much?
I got 11.
11. So far, Landon got the most pennies.
Now I have 6.
And I want you to try one more time, Landon. If you can fish out those pennies with the fork or something, and then try, let's do one more try.
Now I have 10. Quinn has 10.
I got 12 so far,
Mark got 12. Awesome. How much?
and it still hasn't spilled.
Very
Now
good.
I have 11.
Coin then, if you have enough coins.
Now I have 12. And it's spilling
How
over.
was it going, Carmen? Were you able to put pennies?
This is so cool.
So my best score was 40.
40 pennies?
Yes. 40.
Wow. That's a ton.
Yes. And now I want you to think, why do you think, even though the water is all the way up full, how are we able to put so many pennies in it? Can anybody give me an answer for it? Brandon, did you raise your hands? Okay, Mark.
I think since the water's sticky, it must stick inside the cup somehow.
The first part of your answer is absolutely right. Yes, Kaden.
I got 29.
Oh, wow, 29 pennies. Can I put you on spotlight so that everybody can see? So yes, water is sticky. That's why we are able to put pennies in it. You know what part of sticky water is acting here is the top part. Very good, Kaden. We all can see that. Awesome job. Thank you for sharing.
Wait, I think I used a couple coins by accident that weren't pennies.
That's okay. So the top of the skin of the water on top, it's the molecules are sticking to each other like tiny magnets. They are creating a thin skin on top of water, and you are putting so many pennies in it. Even though the volume of cup is going up, those molecules, they just don't want to break and cause a spill. So they are holding on to each other so tightly. That is why you are able to put that many pennies in it. So that is called water's surface tension. Yes, Landon.
I got 14.
14. Awesome. Great. Awesome, guys.
I probably could have got at least 100 of them in there if I didn't run out of coins.
So yes, that's a challenge. try it after the class whenever you get time this week, and share your score. Write down on the parent letter and share it with me later how many pennies you were able to put in it, and how strong the surface tension of the water is. So now let's do another experiment to check the surface tension. Okay, I want you to take a clear plate, sorry, not clear plate, a clean plate. You can use the same plate you are working, you put the water on. So I'm going to dump this water in a big cup so that I don't spill it. And I will show you what I'm doing here. So here, okay. So what I'm going to do is I'm going to clean this plate. So I'm going to dry all the water. I don't want any water on this plate. So I want you to dry your plate fully. And take a dry penny, okay? So make sure your penny is dry. So I'm going to take one penny and make sure the penny is totally dry. And take a little bit of water in a small cup or whatever cup you have. Okay. And we will use, how many of you know how to use a pipette?
Mostly all
You
of us.
explained to us last time.
Okay, if you don't know, please wave at me or unmute yourself and let me know so I can explain before we start the experiment. Carmen, do you know, honey, how to use a pipette? Okay, awesome. Thank you for the thumbs up. Okay, what's the challenge is to put drops on top of this penny with the help of pipette. Now I want you to write down the prediction first. Let's predict how many drops of water we can put on top of this penny. Can you write down on a paper the number and show it here to me? And I'm counting down. 5, 4, 3, 2, 1. Yes. Kaden, please show it right on the screen so that everyone show it on the screen what number you have.
I have
15.
I have 3.
Okay. 10. Okay. Keegan, your camera is a little bit blurred. Can you unmute and tell me what's the number is? How about you, Sawyer? What's your prediction?
So Sawyer's is doing that.
Okay, so Keegan, I think okay. Sawyer, what's your prediction?
7.
7. Mark, what's your prediction?
Probably 9.
9. Okay, so let's all start together. Make sure the plate is dry and make sure your penny is dry before you start this experiment, okay? And I'm going to do that too. So once it spills over, you'll stop, okay? 4, 5, 6.
1, 2, 3, 4, 5, 6, 7, 8, 9.
Mine was 30.
11, 12, 13, 14, 15, 16. I was 16. Wait, I might be able to add one more. 16, 17, 18, 19, 20, 21, 22, 23, 24. Oh, I'm out of water. Okay.
So
25, 26, 27. Oh, I got 27.
very good. So this is 24.
I got 30.
And if you look carefully, what shape did it form? What shape do you think it is?
It started going on top of the penny, like sort of like it was like a sandwich, kind of.
Very good. It's like a dome shape. Why do you think this is a dome shape?
Because when it doesn't have, it's not like in a jar, then it will take whatever shape it can find.
So very good. Thank you, Quinn. So when we put the water in the cup, you saw that it made a dome shape on top, and it's the same shape it made it on the penny. So the dome shape, the sphere shape is it's a natural shape where you can put the maximum volume inside the sphere and maximize the surface area. So here, if you look carefully, the water is sticking to its molecules. It doesn't want to go out of penny until we just overfill it, and eventually the gravity takes over. Now look carefully. These are 29 drops, 30, 31.
When I did it the second time, I got 39.
Wow.
I got 37.
32 here. Wow, 37 drops, 39 drops. Those are big numbers. Oh, I only got 33 and then it spilled over. Now, this shows how strong water's surface tension is. How the molecules, each and every molecule of water is strongly holding hands together and not letting go. That's what makes water sticky. Isn't that cool? So these two experiments, what we did just now, you guys can do multiple trials just like a scientist and share your score with me, how many you were able to do before the surface tension broke up, okay? Now, I want you to take your tube out and fill, you can use the funnel. If you don't have a funnel, please take a grown-up's help and fill half of the tube with water, okay? Like this. Oh, I put a little bit more than half, so just eyeball it. Doesn't have to be really accurately half. So like this, okay? Once you have done that, I want you to take the mineral oil out and fill rest of the tube with mineral oil.
What is a mineral oil? The white stuff?
Yes, you must have got something in a tube.
So can I put it for my funnel or no?
Yes, you can.
Is it okay if I mix in the funnel?
Yes, you can. Later, you can just wash your funnel with soap and water. That will be fine. So I'm going to put the rest.
It's like normal water.
Yes, it's clear, right? It looks like water. So it'll look like something like this, right? Now the question comes.
Wow. It's so cool.
Okay, both are clear. Now, let's say you don't know which one is water. Which one do you think will be water? Top?
One at the bottom.
Now, if you said bottom, why do you think the bottom one will be water? Mark, yes, thank you for
Because the bottom one seems to be darker. The top one looks like a big air bubble.
Let's think scientifically here. Okay, let me just flip my tube upside down. Now, which one do you think is water? Who's going to answer this? Which one do you think is water, the top or the bottom? We did something last week related to this. Yes, Landon.
How do you think it?
Oil would sink
The water is on the it's still on the bottom.
Well, the top of the tube.
Well, yeah.
Turn it the other. Now-
Okay, it's the opposite what you said. The oil is lighter than the water. The oil density of oil is less. Oil is less dense. So it's going to float on top of water. Thank you, Landon. That was a good thinking. I want you to all think. And now let's flip it back to the right position. Now, when you flip back, water will go down and oil will float up. Now, since these two are clear, it's very hard to see, right? Now let's put few drops of food coloring.
So when I shook mine up, it makes kind of like a volcano. It bubbles. It's
Yeah.
So cool.
Now, before you put food coloring, who is going to tell me what will happen to the food coloring? Do you think food coloring here is water-based? What will happen? Quinn, yes.
It won't mix with the oil.
It won't mix with the oil?
I mean, it won't mix with the water.
It will not mix with the water. Okay. Anybody else
I
wants
think
to add?
the opposite.
Okay, so Mark is telling it will not mix with oil. Okay, anyone else wants to add or tell me?
We learned last week that like the dye is sort of an oil base, and so it'll mix with the oil, but oil doesn't mix with water.
So that dye must be oil based, but this coloring, food coloring, is usually water based. So let's check that out. Okay, so I want you to open the tube and put like 3 drops of oil, food coloring in it. When you're putting it, please observe what's happening. Okay, so what just happened here? Can you all see my tube?
Hey, it's floating in the middle.
It's floating in the middle.
Try stirring the water up, and when the bubbles go up.
Now what happened?
Oh.
Can you all see that?
Mm-hmm.
The bubble broke.
Yeah, right. Mixing with water.
So who wants to share their observation? Landon, yes. Unmute yourself, honey.
It floated in the middle and then it sunk down, but you can kind of see it bubbly. It's a bit bubble. So yeah, and on the sides you can see a bit of food dye.
Very good. Is it mixing with water or oil, Landon? What do you think?
Water.
With water only. Why do you think that's happening?
Oh, I know.
Yes, Mark.
So I think since the colors might have a certain weight of each other, and it might the colors might be heavier than just normal invisible oil, and it might want to mix with the water since it's heavier.
That's a good, okay, very good. Carmen, yes.
Here, just see.
Okay, never mind. Mine just when
Hold
I.
on, she can't. Oh, I'm sorry.
Okay, never mind. Mine just eventually like settled.
Yes,
But for a
right.
while,
Now
it's
we're
just
going to do
all-
that right now. Very good, Carmen. That's a good thing. Did you shake it? Yes, okay. So what happened when we put the the food coloring, since the food coloring is water-based, it did not mix with oil. It went because water-based, it's heavier than oil, it went down. But when it went down and it touched the water, since water is sticky and food coloring is also has water in it, the water molecules in the food coloring and water molecules in the water, they just joined together, just like hydrogen bonding, just like I showed you, they just held hand together and mixed together. So that's what just happened. Now I want you to really shake it well and see what happens. Shake it really hard. What Carmen did. Awesome.
Like totally, it looks like snow or hail.
Yes, so now, once you have done it, now just leave it undisturbed for like few seconds or at the most a minute, and then see what happens. What is your prediction? What will happen? Who's going to share? Quinn. Okay, Landon. Yes. What's the prediction?
So I think it will just turn back.
It means the oil will just separate out. Okay, who else wants to share? Mark.
I agree with him.
Okay, so yes, I believe that too. How about Kaden, Sawyer, Keegan? Do you guys agree? Do you think oil will separate?
If you look at the bubbles carefully, you can see the bubbles are kind of like separated. If you look, you can kind of see like a visible line.
So if the lava lamp is similar to this is how they make it. If you put an Alka-Seltzer tablet in it, it will become a lava lamp, actually. So.
Sorry, I froze.
Oh, that's okay. So observe this tube, do it different ways, like sideways, and see whether oil and water are still separated, upside down, and check the density and the surface tension of water molecules, and share your observation with me next class, okay?
I just did an experiment right now.
Yeah.
If you can see it, there's kind of like a bubble, which when you move it, it kind of moves this side, then it moves the other side. But this side goes away. It doesn't like stay half and half like it was. It kind of moves.
Hey, did you know that's actually how they make some sort of measuring tool?
Come again? What did you say, Kaden?
So we have like a measuring tool that measures if it's uneven, like straight.
Like a level.
A leveler, yes. In construction or when you're putting a nail on the wall, yes.
Mm-hmm.
It's similar to that. Very good observation. Awesome. Yes, Landon.
I'm kind of adding on, but you can kind of see that there is an air, so it's kind of actually like a level.
Yes, you're right. Good observation, guys. Now, yes, unfortunately, it's 3 minutes. Okay, so we will have to sign off. But if you have any questions or you want to share your observations and data with me,
Questions or comments?
Next class, okay? Okay.
Okay.
Bye. Bye-bye. Have fun. Have fun.
Bye.
Bye.